So we have said that oxidation is the loss of electrons and reduction is the gain of electrons. But why is it when electrons are lost, the oxidation number would increase? So if you think about how electrons have a negative charge, when something loses electrons, its charge will become more positive. So when electrons are lost, the oxidation number goes up for the same reason that the charge would increase. And there's two ways that you might choose to remember these definitions of oxidation and reduction. The first one is oil rig. And that stands for oxidation is loss and reduction is gain. And of course there, what we're talking about is of electrons. So oxidation is loss, reduction is gain. So our acronym there, oil rig, helps us remember that. And the second one is Leo says Ger. So that would be loss of electrons is oxidation, gain of electrons is reduction. And you can use either one of those two acronyms to help you remember those processes. Okay, now it's time to use the oxidation numbers to determine whether or not something is a redox reaction. So on the first page of notes, we said a redox reaction or oxidation reduction reaction is one where the oxidation numbers change from the left side to the right side. So here are some equations, and what we're going to do in order to determine if they are redox reactions is we're going to assign oxidation numbers to all of the substances in the reaction, and then we're going to look to see if they change, and if they do, we know we have a redox reaction, and if they don't, we would say that's not a redox reaction. So I'm going to do the first one for you, and then I'll give you some time to practice, and then you can see what the answers are. So in this first compound, H2O, we have rules that oxygen is always -2, and in a compound, unless it's a peroxide, which it's not here, and hydrogen is usually +1, unless it's a hydride. So we know hydrogen is +1 here, and oxygen is -2. And remember, we have a 2 as a subscript on that hydrogen there, so that's telling us we have 2 positive ones to sort of balance out that charge of the -2. Okay, now we have iron as an element here all by itself, so that's going to be a 0. Any elements in their standard states at room temperature are going to be zeros. Okay, and then we have hydrogen over here, another element, so that's going to be a 0. And then we have a compound with iron and oxygen. So we have a rule that says oxygen is going to be -2 when it's in a compound, unless it's a peroxide. And there are 3 oxygens, so our negative total is going to be -6. And then we have 2 irons, and so together the 2 irons have to have a total of +6 so that we sum to 0, and that means each iron is a +3. And that makes sense if you think about it, because that compound is iron 3 oxide, and we learned that a monatomic ion like iron 3 will have an oxidation number equal to its charge. Okay, now if you take a look, what you should notice is that hydrogen is changing from +1 to 0. And iron is changing from 0 to +3. And so 2 things that I'll point out about this. The first is, when something is a redox reaction, you should have one thing that's increasing and one thing that's decreasing. And if you don't, that's a sure sign that you've assigned some numbers incorrectly. And the second thing is, you won't have just one substance changing in oxidation numbers, but no other substances are changing. It is possible to have one substance that will change in 2 different ways. One substance can both increase and decrease. That's a rare case, but it does happen. So what we can see is that hydrogen is going from +1 to 0. So that is a reduction. So let's make a column for that. Hydrogen is being reduced, and iron is going from 0 to +3. So that's going to be the one that is undergoing oxidation. And you should notice that oxygen is -2 on both sides, which means it is neither being oxidized nor reduced. So When you see the oxidation number is increasing, that's going to be oxidation. And when you see that the number is decreasing, that's going to be reduction. Now, pause the video and try the rest of the examples, and then play so that you can see the answers. Okay, take a few minutes to compare your answers to mine. After you've compared your answers, I'd like you to answer the 2 questions that are below this chart. So first, look at the types of reactions that you learned in your first year chemistry class, and look at the reactions that you have here, and try to create a rule for yourself. What types of reactions will always be redox reactions? What types of reactions will never be redox reactions? And then look at your answers in the box and try to create a rule that relates the position on the periodic table and the likelihood of being oxidized or reduced. In other words, what kind of elements are likely to be oxidized and what kind of elements are likely to be reduced? So one of the ways it's easy to identify a redox reaction is if you have an element in elemental form on one side of the equation, and then it's part of a compound on another side of the equation. So that would fit into the always redox category. So one example of that is single displacement, because in those reactions, you have an element on one side that becomes part of a compound on the other. So that would be like the third example here. Another type would be synthesis and decomposition, but only when you see examples that you see here, like this one, and I guess we don't have a decomposition, right? So when we have a synthesis reaction where the elements are becoming a compound, or a decomposition where the compound is becoming elements. There are synthesis and decomposition reactions that wouldn't always be redox, but the ones that involve elements on one side and a compound on the other would. And then the other one would be combustion. A combustion reaction is always a redox reaction. Okay, one that's never a redox, though, would be double displacement. So in a double displacement reaction, you have all compounds. And if you take a look, we have a double displacement reaction here and a double displacement reaction here. And notice that those are the 2 that were not redox. Okay, and then we take a look at the second question. We know that metals are more likely, when they're forming compounds, to lose electrons. And that means they are more likely to oxidize. Whereas nonmetals are more likely to gain electrons, and that means they are more likely to be reduced.